sticky ice experiment. For that we have with us salt, ice cubes, water and a thread. In this experiment we will first try to lift a cube with thread, and as applied by logic, a thread can't lift a ice. So we will try something new. What we will do is we will pour some ice cubes in water, and then we will place our thread through that water. Now we will take salt and sprinkle some salt on that thread and inside the water. Now we will wait for a few time and we'll see what happens next. So now after 2 minutes we can see that spring has lifted the ice cubes. How did that happen? As we sprinkle the salt on the ice, it starts melting, just as salt added on icy roads does in winter. We all know that water freezes at 0 degrees Celsius, but when salt touches the ice, it lowers the freezing point to much lower than that. In order for ice to melt, however, it has to absorb heat. The heat that is absorbed comes from what's around it, which in this case was water near the ice cube. Some of this water becomes so cold that it refreezes and the string becomes trapped. The string is now stuck and you can lift the ice cube out of the water just like that. So that was it. Today in this experiment we will learn about refraction of light. We have with us a glass filled of water. We have drawn two arrows which are facing in the same direction. Now, as we can see, I have drawn two arrows that are facing in the same direction. But when I look the arrows from the water, then we can see clearly that the arrows are facing in opposite direction. But in reality, on paper we have actually drawn the arrows in the same direction. But again, when we see through water, the arrows are flipped. That is, the image is being flipped. Then why is the image being flipped when we see through the water? The reason is, when the light from the paper enters our eyes, between that path, it also has to pass through glass, then water, then it enters the glass again, and then it enters the air once again, and after that the light goes into our retina and forms the image. So when light travels through these different mediums, that is air, glass, water, as we all know, the speed of light is different in different mediums. That's why the light gets refracted. That is, the light bends towards the normal. When light travels from a denser medium to rarer medium, light bends away, and when light travels from rarer medium to denser medium, light bends towards the. This phenomenon of bending of light is called refraction of light, and that can be easily understood and illustrated by this simple experiment. Hello, so in this video we'll learn about buoyancy and density. So we have with us a water bottle, orange, and orange peeled off. So first, when we put this orange in water bottle, then it floats. It floats due to density. We all know about density. Density is mass upon volume, and buoyant force is the force that is exerted by fluid on an object that is submerged in it. So as the rind has air pockets in it, so the air trapped in that rind decreases the density of oranges, and that makes the orange sink. But let us see what happens when we put a peeled off orange in the same water bottle. As the rind is removed from the orange, the air pockets are removed as well. So the density of the orange increases, which makes the orange sink in the water.